Hi everyone. Today I'm going to show you how to do the rotation of a square in 2D space. If you haven't seen the previous video I've made about a basic square in 2D space and how to draw that, you may want to start there. However, today we're going to go ahead and cover how to rotate one. So all of the steps at the beginning are pretty much the same. We're going to define our width, our height, our origin X and origin Y, and go ahead and plot those based the same way we did in the first video. And the next step we're going to do is we're going to go ahead and calculate our length based on our origin point and our first point in space, which will be this bottom left corner. And then in succession, here's our second, our third, our fourth, and then our fifth point is actually closing the square back to our initial point. So before we can rotate this, we need to figure out our initial degree from the origin to each of these points. And that's what I've done. I've taken the origin point and subtracted it from our new point in space, and the arctangent of that division plus 180 degrees will get us 225 degrees, which is this bottom left. So I've done that for each of these four corners. You get negative 45 degrees from a straight out 0, 45, 135, and then our closing at 225. After that, we have to calculate our new x-coordinates after we transform it by rotating about the z-axis. That's what each of these columns are for, our x new and our y new. And our x new takes the cosine of our initial angle, adds the degrees that we're going to rotate it by, multiplies it by our length, and then we add our offset so we can move our square around in space. And I've done the same thing for y, except I'm doing the sine. That's the same for each of these 5 points. So as we rotate it, you'll see these x new and y new update, and all I'm doing is calculating where that line in space from the origin to our initial point, how far it rotated, and I'm replotting each of these in that same location, or the new location that's been calculated. And it'll just spin forever as long as we keep increasing our degrees, or our radians if you will, and that's basically it.